Okay, in this example, we're going to look at a very classic problem for finding work. Here's a scenario. You have a tank which is in the shape of an inverted cone. It has a height of 10 meters and a base radius of 4 meters. So right here is 4 meters. It's filled with water to a height of 8 meters. So that's water until 8 meters. So it's 2 meters off the top is empty. And then you have to find the work required to empty the tank by pumping all of the water to the top of the tank. Okay, so just think of it like if there is a suction pump here and you're trying to pull all the water out from the top. And you're given that density of water is 1000 kilograms per meter cube. So first of all, let's introduce a coordinate system. Let's call it x. And let's say right here is 0. Then if you look at each of these little shells, and you can see that the thickness is delta x at some radius, right? So what we can do is, let's look at this triangle here. This right angle triangle, right, on the cone, this is 4, this is 10. At any distance x, right? If this is x, then this is 10 minus x. This is Ri. Now what I have is, using similar triangles, I have some ratios that can be equated. For example, from the small triangle, 10 minus x over the radius equals the height of the big triangle over 4. That gives me 40 minus 4x equals 10 Ri. Right? Or it gives me Ri is 2 over 5, 10 minus xi. So the volume of the thin disk is 2 pi Ri times the thickness. So it's 2 pi area. So it's pi Ri squared. So it's pi 2 over 5, 10 minus xi squared delta x. Right? What this becomes is 4 pi over 25, 10 minus xi squared delta x. Now the reason they're given density is because you can use the relation mass is density times volume to get the mass of that water. So how much water is in that layer is mass, okay, so what's going on here is that we have mass is density times volume. So in this case, the mass is going to be density, which is 1000 times 4 pi over 25, 10 minus xi squared delta x. That's going to be the mass. But then, once you have the mass, the force that much water applies is going to be mass times acceleration. Right? So that's going to be 9.8 times the 1000 times the 4 pi over 25 times the 10 minus xi squared delta x. And this comes out to, if you evaluate all the constants, 1568 pi 10 minus xi squared delta x. But that's the force. Now what is the work done? The work done is going to be the force times to raise that, the amount of work done in order to raise that particular layer. Now each layer is at a distance of xi. So the work done to raise that layer is 1568 by xi 10 minus xi squared delta x. Now this under the limit, it becomes the integration of 1568 by x 10 minus x squared dx, and x varies from 2 to 10 because remember there's only water starting from 2 meters below the what we chose as origin. If you complete this, this should come out to approximately 3.4 times 10 to the power 6 joules.